right, good morning, everybody. The computer tells me it's 10 o'clock. All right, so let's start with announcements like usual. And like usual, we hope and pray the clicker works. And like usual, it's not. Nothing's working. Okay, so Cybersheep, your last round of decisions are due Friday. So put that on your calendar. And also, there's team evaluation form that will be put on Canvas, or is on Canvas. It's currently on Canvas. Those are due in class, so we'd like to have a hard copy on November 30th. So that is evaluating yourself and your teammates' performance. And it's worth 10 points, I believe. So it's a good way to kind of help your points out and give credit where credit is due. Okay? No questions about those things? Okay. Well, let's just jump right into it. So last time, if you remember, I had a slide up and I had some thoughts to ponder regarding the breed assignments. Okay? You guys pondering out loud right now, or can we? Okay. Need everybody to focus. So we started talking about those dog DNA tests, and I wanted you to think about some of the things that go on behind the scenes that get us to the answers that we're discussing. And we're going to come back to that with dogs and your cattle data towards the end of lecture today. We started talking about hybrid vigor. So one of the reasons that crossbreeding is so important in our production systems is because it gives us this thing called hybrid vigor, right? So that's an increase in gene combination value due to those interactions between alleles at a particular locus. So we defined hybrid vigor, right? Does anybody want to tell me how we defined it, since people seem to be talking amongst themselves? What is hybrid vigor? Yeah. Okay, so thank you very much. It's the benefit, still doesn't work. It's the benefit gained by crossbreeding. So it's a benefit gained by having heterozygosity. And we often quantify it, saying how much better is that F1 than the average of those parents. Okay? So we do a subtraction. What is the average of the performance of those parents from what the performance of those F1 is? Okay? So started thinking about hybrid vigor, and then we got into the idea of retained hybrid vigor. And if you remember, we went through the example, if we crossbred two breeds that had different allele frequencies, so very different allele frequencies, that hybrid vigor is maximized in that first generation, maximized in the F1, but you still have a benefit of hybrid vigor in that F2. However, it's just not as high as it was in the F1. So we ended last time thinking about how we can calculate retained hybrid vigor, or that hybrid vigor that is still there, even though your cross isn't an F1 cross anymore. Okay. So we're going to finish that example, put on the board where we ended talking about direct or individual retained hybrid vigor. We're going to look at the maternal component, and then we're going to go back to those doggy and cattle DNA breed tests. Okay? All right. So as I just defined, our retained hybrid vigor is what we have in generations after the F1. Okay? So it's the heterozygosity that remains, given that we started crossbreeding two usually purebreds. Okay? We usually express that as proportion of the maximum. So the proportion of what I would expect in the F1, how much of that is still around. Okay? And then we put up this equation, and we started using it. Okay? So it's saying our estimated retained hybrid vigor, again our hat, right, means our estimate, our predicted. It's going to be 1 minus this kind of ugly looking thing, right? We have a summation. We have PS and PD. So PS is a percent of that particular breed I in your sire. PD is a percent of that particular breed in the dam. We have to consider all the potential breeds that might be comprising those individuals. And we're going to say what proportion of the full hybrid vigor, of the F1 hybrid vigor, is left. Right? I want to know, what did I lose by crossing them in this situation? Okay? So let's look at our example. Okay, so this is our example. We were talking about Brayford cows. So they're 3/8 Hereford, 5/8 Brahman. And we're crossing those cows with the Brahman Charolais, 50% each bull. Okay, so up on the board I had our breed portions. I used B for Brahman, H for Hereford, C for Charolais. So our cow is 3/8 Brahman, 5/8 Hereford, and there's the sire portions. And here's our equation. Okay. And to me, when I look at this, okay, what am I going to need to do? I need to figure out what my N is. And you all told me that my N was 3, because there's 3 breeds that are represented in those 2 parents. And those 3 breeds are Brahman, Hereford, and Charolais. So I need to make sure when I do this summation, I'm going to account for each of those 3 different breed components. Okay? So we have 1 minus this. And I mentioned it before, but I want to make sure that this makes sense intuitively to you. If we had 1 minus 0, it'd be 1 times the F1 hybrid vigor. That would tell me that I'm still going to have all the hybrid vigor I had before in this next cross, right? The only way we lose part of our 1, we lose a percentage of that hybrid vigor, is when both mom and dad share a breed component. They share ancestry from a common breed. And in the proportion of the loci, which we find by multiplying their breed proportion for that breed, when those alleles come together, that makes homozygosity again. Or we think about non-heterotic loci. They're both coming from, in this case, the Brahman component. And so if they're coming from the Brahman component, they're not giving us hybrid vigor anymore. So we have to subtract out that proportion of the loci. Okay? So in our example, we're not subtracting out anything because dad doesn't have any Hereford. We're not subtracting out anything here because mom doesn't have any Charolais. So there's no way that a Charolais allele can come together from each parent. But we are subtracting out the fact that 3/16 of that animal will be homozygous, if you will, Brahman. So we take 1 minus that proportion. We say, okay, so this is going to be about 81% of what we had before. 35 is our maximum hybrid vigor, and that gives us a direct or individual hybrid vigor of 28.4 pounds in that calf. Does that make sense? Happy? Okay. But remember, we talked about 2 types of hybrid vigor. We talked about individual, and we also talked about hybrid vigor that a calf can get if its mom, for instance, is herself a crossbred. Maybe that mom being a crossbred is going to produce more milk. She's going to take better care of that calf, and that calf's going to benefit not only from himself being a cross, but from the fact that mom was a cross. Okay? So now we need to think about that part. So our maternal hybrid vigor, I'm going to tell you like I did before, predicted hybrid vigor in the F1 due to maternal heterosis is 45 pounds. Okay? So we're going to use the same calculation. Your little hat for estimated retained hybrid vigor. In this case, we're looking at just mom. We have to look at the breed proportions. You're going to see how much of that maximum hybrid vigor we expect. Whoops. PD. So mom is, what did I say she was? 5/8 Hereford. Mom is 3/8 Brahmin. What do we need to know? What else do we need to know? Bless you. To fill in this. We need to know what her sire and dam were, right? We know that she has those components, but we don't know exactly what her sire and dam are. So in this case, we're going to assume that mom, our Brayford cows, are mating between sires and dams that are themselves 3/8 and 5/8, those breed components. Bless you again. Okay. So when we do our math, 1 minus, so let's take into account Hereford first. So what proportion of mom is, what proportion of mom's dad, what proportion of the sire in this instance is Hereford? 5/8. And I said we're just mating individuals that are alike, right? So mom's also going to be 5/8. We have to add, we need a parentheses here. There's so many parentheses. Then we're going to account for the fact that mom and dad are each 3/8 Brahmin, right? And we're going to take this whole thing times the maximum hybrid vigor we would get. Okay. So right away, do you think this answer is going to be close to 45? Are you going to have a lot of that hybrid vigor remaining? I see some head shaking no. Mike is saying no. It's really, we're going to lose quite a bit, right? Because mom and dad both have similar breed compositions. They both share ancestry from 2 breeds. And so we're going to be subtracting out that. So we have 1 minus, this turns out to be 25/64. Again, these parentheses are get you. 9/64. So all that times 45. And if we do that math, it turns out to be 21.21 pounds. Okay. So our calf, because his mom has this breed composition, and assuming that her parents had the same breed composition, is going to get a benefit, going to get a bump of 21.1 pounds. We're talking about weaning weight from mom. Okay. But calf gets both things, right? Calf gets a benefit because he's a crossbred, because he has hybrid vigor of 28.4 pounds. He gets benefit because his mom is. And so then we can then find a place on the board to write this, but we can calculate his total retained hybrid vigor that we would expect. It's going to be those 2 components, 28.4 plus 21.1, or 49.5 pounds. Okay. So we expect that calf to be 49.5 pounds better, right, than another calf that doesn't have the hybrid vigor component. Questions? Yeah, Renee.
Why do we have to include hybrid vigor of the sire?
So the question was, why don't we include hybrid vigor of the sire? I won't say that boys don't matter, but when we're talking about how the calf's weaning weights, the component he or she gets from mom or dad is largely going to be in that mom's maternal behaviors and her maternal qualities. If we kind of ignore dad in some ways. Yeah, Sophie.
Why wouldn't they get half of the hybrid vigor if it's the mom?
We're already, so why they would, say that again.
You know how when you have the sire and they give half a lot of times their qualities to babies? would they have a full effect?
So I think you're asking a similar question, and we're seem to be only focused on mom here. And our F1 hybrid vigor here that we're taking into account in this calculation is just due to mom. So we don't half that because we're already accounting for it just being attributed to mom. Does that make sense? Okay. Good questions? Anything else? Okay. So you also may want to think about hybrid vigor attributed to, in the case of percentages, and we alluded to that earlier, in that what we end up doing here is calculating in this big bracket parentheses is the proportion of the total hybrid vigor we would expect. And so in our case, we are subtracting out, like I said, 0.1875 from 1, or we are maintaining 81.25% of hybrid vigor. So that's our percent hybrid vigor retained. Okay. So those are the three components. We're saying we're subtracting out the fact that both those parents share ancestry, that's Brahmin in origin, and giving us that percent hybrid vigor. Okay. Okay. So I'm going to show you, actually, when we get later to our cattle DNA results, I'll show you a schematic of this, and we talked about it a little bit, but we start with our hybrid vigor. We often think about our purebreds. So we have our maternal line, we have our paternal line being selected to do things that dad should do well and that mom should do well. Usually the sire breed is putting on a lot of muscle quickly, and mom's has some maternal traits, such as milk. But when we get to those future crosses, when we get to that F2, those alleles segregate due to Mendelian sampling, right? So we're going to lose heterozygosity, and then the alleles which maintain heterozygosity are going to be randomly distributed across those progeny. Okay. So our final example, we're going to think about predicting performance of a crossbred. So in a little different way. And I'm going to think about feedlot performance in this situation. Actually, I grabbed the wrong example, so I'm not. Wrong piece of paper. Too many examples. I lost my example. Okay, we'll come back to that. Similar to what we talked to with estimating proportion of heterotic loci. If you know which loci, what proportion of loci are coming from which breed, and you know the performance you expect of the purebred, you can use that proportion of ancestry to estimate what you expect in the crossbred animal. Okay. So sorry about that. I'll find that example. We'll get to it next time. Okay. Questions on that? We're going to get to talking about dogs and cattle. Okay. Okay, so I'm hoping, as I alluded to last time, that we can have a little bit of a discussion about this amongst ourselves. And I want to think about why in the world would we do this assignment testing that we've been talking about. I suggested that it helps us understand which parts of the genome of an animal come from where. If we know, for instance, that we want a dog that has some good retrieving abilities, we want to make sure that it has some maybe Labrador Retriever, right? And if we could, we'd want to make sure that those genes that help with that dog retrieving ability come from Labrador Retriever and not from the other part of that cross. Okay? So this is our example of Keisha again. She's been quite famous in this class. And we first talked about one DNA test that said she was half Cocker Spaniel and half K breed, right? Mary can correct me. Mary's Where's Mary? But the other DNA tests suggested that she has components of Australian Shepherd and Dachshund. Okay? And I said, what in the world's going on? What do we trust? Okay? These are the questions that I brought up. Okay? Read through those again, and we're going to come back to these. Okay? Okay. So, Emma? There you are. So Cooper, supposed to be mostly Springer Spaniel, right? Anything else about Cooper that you want to say? He's cute. Okay. So could we genotype Cooper? Cooper came from Springer Spaniel Rescue, and the results say that Cooper is primarily English Springer Spaniel. Good, right? It's kind of what we expect. But they said there's 12.5%, so 1/8. So going back past 3 generations, that they can't assign exactly, and they give groups rather than breeds. Say we can't say for sure he's this one breed, but we think pretty sure that he comes from type of dog that are mountain dogs. So if you click through there, it gives examples: Leonbergers, St. Bernards, so some of those big dogs, maybe some terrier, and maybe some herding group. So Cooper, based on their test, doesn't look to be quite pure. So we'll have another example. So Kitty already had the Wisdom DNA test, and this is what the results that Liz shared show, that Kitty is quarter Labrador Retriever, 1/8 Springer Spaniel, 1/8 German Shepherd, 1/8 Golden Retriever, and then Kitty's kind of mixed up too, where they can't figure out what the rest of Kitty is, and actually quite a bit of Kitty seems to be mixed up. So we wanted a second opinion, right? So we sent DNA also to that other company, and they said that Kitty has level 3, which I believe is 20 to 36% Labrador Retriever. Fits? Happy? Okay. Said that Kitty also has a level 3 German Shepherd. So again, the prior test suggested that it was more like 18%, 1/8 German Shepherd, but we still agree in those 2 breeds. They also said Kitty is level 4 Brittany. Okay, Spaniel, maybe, right? Maybe there's crosstalk going there. And level 4 Shetland Sheepdog. What do you think?
She's smaller, but some of her litter weights are 75 pounds or bigger,
Okay,
and she's only 45.
so she might have gotten some recessive alleles or some less benefit from heterotic loci. But the question is, it's the same dog, right? DNA is DNA. Swab the same dog twice, send it to 2 different companies. Back to the question of why, and which do you trust? Do you trust either? What do you guys think? When you get to cattle, we're going to have a similar conversation, foreshadowing.
Does it depend on the ones they use for like their reference?
Okay, so I think that's a good idea. So the question was, does it depend on what they use as their references? I think that's probably true. And do you remember when Dr. Lewis talked about genomic prediction? I think I copied one of his slides up here in a little bit. We'll go to that. We said one issue with genomic selection is we're relying on a marker telling us about some phenotypic trait, and it has to be consistent, right? And generally those things are consistent within breeds or within the population that you discover them in, and when you apply them to a very similar population. But when you don't have a good discovery population, you might lose those relationships. So I think you're absolutely right, and maybe their reference populations are different. So they might have discovered their markers or discovered what they're using in a certain set of dogs, but we all know that there's a lot of diversity in dogs. So along those lines, this is the second test, the DNA My Dog test. They test for 95 different breeds. I know you can't read this, and I love it when people say, you can't read this, but here it is. But 95 different breeds, okay? I emailed them to ask them how many DNA markers they're using, and I haven't heard back. They don't talk about that on their website. And then the wisdom panel, if you can read that, it says their database represents more than 350 breeds based on 15,000 samples from within those breeds. So their reference population is quite a bit larger, right? And I'm not going to say I trust one more than the other because I don't know everything they do behind the scenes. From this information, I would assume that they might have a better ability to distinguish between different populations, right? But here's what a phylogeny of dog breeds looks like. Okay, so you can, if they were labeled by groups, you could kind of see herding dogs over there, retrievers over there, sport groups. But you have to really have a ton of information if you're going to distinguish a bull mastiff from a mastiff, because they're pretty dang similar, right? Or if you're going to distinguish a St. Bernard from Leonberger, so there's mountain breeds that they're assigning some of those dogs to. Okay. So I think these companies are tasked with a pretty difficult problem or question. And maybe in some ways it doesn't matter that much, the outcome, because people who do dog DNA tests are mostly just wanting to know what's the major components of my breed. But maybe it could, okay? So we're going to talk about a couple more results. I'm assigning Daisy the most muddiest award for 2018. Okay. So tell Ray, where are you? Daisy is dad.
Catahoula, Kelpie, Healer, and Pitbull, and my dad is a mini dachshund.
Okay, so dad is a mini dachshund, mom is lots of things. Kelpie, Healer, what'd you say, Catahoula?
Yeah.
And Pitbull. And Catahoulas are interesting because they themselves are a composite of multiple dog breeds. Okay, so let's see what Daisy's test showed. Sure enough, it looks like dad must have been miniature dachshund because she's 50% from the DNA test. Say that she's then 1/8 American Bulldog, Australian Cattle Dog. So I think Kelpie and Australian Cattle Dog sometimes get called the same thing. Bulldog, and then another 1/8 mixed breed. Okay. And then again, our second opinion, without the suspense this time, our second opinion brings out Dachshund, Belgian Malinois, and Basenji. Very, very different answers. The Irish Setter and St. Bernard. Okay. So I look at that picture of Daisy, and I'm trying to see Belgian Malinois. I mean, she has 4 legs like a Malinois. And okay. Okay, so Daisy gets the award. So again, it goes back to those questions of what did you want to learn from this? And are you happy with the results? Right? So our final dog example is Calliope. She's Australian show line shepherd, and there are pictures of her parents. I don't see Mary. Is Mary? She's not here today. We're talking about her dog. Okay. But she also told me that both of her parents have this genotype NMDR1. MDR1 stands for multiple drug resistance 1. And it turns out this is a pretty important mutation. So one of the reasons we decided to genotype Calliope was to find out what her genotype is for that particular mutation. So she genotyped to be 100% Australian Shepherd. And I showed you this plot, I believe, with another dog earlier, in that there's a variation, right, of dogs that are Australian Shepherds. There's where she falls within that variation. And if they compare Australian Shepherds to their outgroup, to other breeds, there's where she falls relative to the other breeds. But think about, set my pointer down over here. Think about if you're trying to identify what one of these dogs is here. Pretty hard to do, right? Where you draw that bubble might be pretty subjective, unless you know that this dog right there is supposed to be a purebred papered Australian Shepherd, right? But these companies don't know. They don't ask. They used to. Some of them used to ask for a picture and for what you know about your dog, which is kind of, I think, cheating a little bit. But these companies don't know, and we send them doggy DNA, what they're supposed to find, okay? So the question is, how good are their methods to assign animals that fall in those peripheries? Okay. So what else does it tell us about calliope? It gives, for purebred dogs, gives you this information as well. And so there's homozygosity on the x-axis, and this is for Australian Shepherds, and it shows us that probably about the average homozygosity in Australian Shepherds is about 62%. Okay. We talked about how breeds are inbred largely, and she seems to be just a little bit to the right of the curve as a representative of that breed. For a comparison, we genotyped last year a purebred boxer named Daisy, so not the other Daisy. And if we can see the scale here, the average homozygosity in boxers is about 75%. So showing us differences among our breed types. And boxers are known to be one of the more purebred breeds. That's one reason that they were used to sequence a reference genome for dogs. It was a boxer. Okay. And finally, what did we learn about Calliope's genotype for MDR1? So this is a Mendelian locus, and it tells us that she's at risk, and she has one copy of that particular mutation. Okay? So I would argue that maybe the breed results aren't going to change much about how you treat your dog and how you care for your dog, but this result might make a difference. Right? Has anybody heard of this? Anybody have a dog that has it? It's pretty common. It's very common in the Australian Shepherds. A lot of those similar lines have it. But what this gene does is it limits the ability, or the mutation limits the ability of the body to control the absorption rate of various drugs into the system. Okay? So in a perfect situation, it would make sure that that drug isn't being all sucked in too fast or having an effect. And these dogs that have this mutation, they don't eliminate that drug from their body as quickly as they should. Okay? Some of the drug names are listed there. Ivermectin is the one that you usually hear this talked about with respect to most often, because that's the most common wormer that we use, or dewormer, right? So it's important to know this if you have a dog that's in one of those breeds that's susceptible, so you don't give them wormer and cause them issues such as tremors and ataxia, incoordination, seizures, excessive salivation, or slow heart rate. And actually, dogs can die if they have too high of a dose of any of these drugs. Okay? So what do you do when you go to the vet? When Mary goes to the vet with Calliope, she should say, hey, I know she carries a copy of MDR1, so if you have to do surgery or put her under anesthesia or give her an antibiotic, the vet knows that information and can act accordingly. Okay? So that they can get some of these drugs. Some of them they just reduce the dose, and other drugs they find other alternatives. Okay? Okay. So on to cattle. This is going to be fun. Here's samples that we genotyped. Charmaine gave us samples from 2 cows, Dolly, and she gave me her paper. She's a purebred Angus, and a bucket calf that's Angus cross, you think? You know? Okay, it's supposed to be. Renee had a shorthorn Angus cross, a purebred Angus. Maine, okay, I didn't know that, so the next slide will be wrong. Purebred Maine, and that's her. And another Maine. Dalton gave me 2 samples of club calves, Caden and Dustin, and parentage is known, right? Where's Dalton? No, he's here today when we're talking about their animals. I should just not talk about their animals then. And then Nick, Sim Angus, right? Red Sim Angus cross. Okay. So in addition, Dr. Spangler provided samples from some of our animals in our UNL herd. And he knows based on pedigree exactly what these things should be. 2 purebred Angus, and then 4 animals that are some proportion of all these things, including red Angus. C is a commercial Simmental, so not registered. Black Angus, if it just says Angus, Gelbvieh. I think those are the main breeds that are in the UNL cattle. So we sent these samples to GeneSeq, which is just down the road, and they did what they call breed-seq tests on them. And here's the animals that tested 100% Angus. So the 2 animals from UNL that were registered Angus, so that's good. Charmaine, your bucket calf. So those are 3 animals that tested to be pure Angus based upon their test. Okay, notice I didn't put your other one up there. So other Angus, Dolly, genotyped, and they don't have the big fancy pictures with colored pie graphs and stuff. Dolly tested to be 90% about Angus, 11% Holstein. You okay? Okay. Renee, so 635D, which is which one? Was that pure Maine?
She's supposed to be like 3/4 Maine and 1/4 crossed up.
Okay. So she tested pretty close to Dolly, who has papers as a registered Angus, but brings in some Beefmaster. Sim Angus, Nick's Sim Angus looks to be pretty mixed up. There's a lot of Angus, 40% red, 40% black, Hereford, Wagyu, and Akaushi. Any thoughts there, guys? Delicious, maybe? I don't know. Right? Renee's Shorthorn Angus cross turns, the results say 25% Angus. There's that Beefmaster again. Holstein Jersey, pretty good milky animal, I don't know. And 50% red Angus. So back to these questions of what did you learn? How is this going to change what you do? Do you trust the results? Looking at people who had cattle genotypes. What do you think? What's a Beefmaster? I Googled it because I couldn't explain breed proportions. Anybody know Beefmaster is composed of? Do you guys know? So Wikipedia says they're started with Brahman Shorthorn crosses and Brahman Hereford crosses. So maybe this is pulling out some of that Shorthorn, if our Beefmaster has Shorthorn ancestry in it. We'll go on. So Dalton's animals, they show that they're a mix of a lot of things too. One of them being Santa Gertrudis, which itself is a mix of Brahman and Shorthorn again. So bringing in some Indicus. And then Renee's Maine Anjou comes up with Angus, Hereford, Holstein, Jersey, Red Angus, Santa Gertrudis. Okay. So are you texting home right now saying sell? Or, okay. So what in the world? What do you think? Is it crap? What's that? The cows are mutts. We thought our dogs were mixed up, right? If we had a pie graph with some of these, we'd have so many skinny slices of pie, we wouldn't know what to do with it. So what do you think? So here's a similar circle phylogram of cattle that I showed to dogs. We have our British breeds up here. We have our continental breeds over here. So the Sim Angus, we didn't detect any Simmental. The Maines over here, we didn't detect any Maine. Look where they're positioned with Shorthorns, though. Maine Anjous and Shorthorns are pretty closely related. Okay. So what don't we know about this test that you'd want to know before you decided if it was reliable? What breeds they're testing from, right? I think it's a great idea. I want to know. So here's the answer to that question. 10 breeds, right? So do you see all the breeds that you would want to be represented on your breed test? Ron says no, right? We're missing the continentals. We're missing some really important beef breeds in the US. So the question is, what in the world, why would this be a panel that they were testing? And in full disclosure, when we first started this, I didn't know that it was quite this limited. So what might be a question that people are using the panel, these 10 breeds, to try to answer? The hint's kind of at the top and the bottom. It turns out that GeneSeek started this BreedSeek panel for Wagyu breeders who wanted to be sure that their animals were pure Wagyu. Okay? And these other breeds tend to be the ones that get crossed most commonly with that breed. Okay? So this particular panel, and I talked to a couple of people at GeneSeek just the other day about this, it's really only being used at this point by the Wagyu and Akaushi breeders. Okay? So its purpose is not to do what we wanted to do. Its purpose is to answer a specific question for those particular breeders. They are planning on expanding this. They're working on version 2 right now, and I said, I hope there's going to be more breeds in it. And they said, yeah, we're hoping to. Okay? So, but let's think about, even if they had lots and lots of breeds, this is a principal component plot like we talked about before. So showing most of the variation among these different samples. Each sample is an individual dot. So on the x-axis, then the y-axis also explains a fair bit of the variation. First of all, we have admixed breeds. So our beef masters and our Santa Gertrudis that we talked about, they're falling kind of in the middle because they're mixed up with a lot of other purebreds. But look at this cluster, right? So Angus is in there. Can't even read what all the colors are. Our brown Swiss are in there. Charolais in there. It's going to be really, really hard to pull apart, right? This is using 34,000 DNA markers, these data here. So there's a challenge of having an assay that does a really good job of that. And there's also politics of doing that. When you guys, I told you your purebred Angus isn't a purebred Angus. If that was a 5-figure bull, you might be pretty upset, right? So breeds have talked about this, and I've dealt with this in the horse world as well. Can you do a test to tell me my horse is pure whatever? Like, you have to first, the breed organizations have to first define what they want to represent pure, and then we can use genetics to define that and assign animals to that or not. But using genetics, because of how much variation there is within individual animals, because of how they cluster, it's really hard to use genetics to define something when you don't know what you're trying to define. Okay. GeneSeek folks sent me this slide as well, which I drew in a much more rudimentary fashion before, just using one locus. But another difficulty in doing this well with crossbred animals, this goes for dogs and cattle. Let's say we crossed 2 animals that were a quarter indicus. Okay? And so indicus is represented by red, and we're just thinking about one chromosome, so our sire and our dam. You can get, because of Mendelian segregation, because of Mendel's laws, you can get animals that inherit none of that indicus ancestry to animals that inherit both of those proportions of the sire and the dam at that particular locus and appear to be 50%. Right? All of these calves have the same sire and dam, the same breed background, It's just that they don't necessarily inherit the same alleles from those parents. Okay. Okay. So, what do you think? Are these types of tests beneficial for what we do? Whether it's a dog that you're breeding, whether it's cattle that you're using for production. There's some nods, yes, I think that's good. Why not? Anybody say no, this doesn't help anything. Nobody wants to take a stand, say no. So everybody else thinks it helps. Raise your hand if you think it helps. Okay, so thanks for waking up a little bit. Right? So I think they can be very useful. I'm biased though, right? Because I'm a geneticist. But I think that you have to be very conscientious in what the purpose of the test was, what it was designed for. Are you using it for the right purpose? And the science has to be sound. And it's hard to evaluate, especially with these breed composition dog tests, it's hard to evaluate that, right? It's hard for me to evaluate it, and I deal with this on a more regular basis. So I can't expect that everybody else who might be using it can evaluate whether or not the science is sound. And actually just yesterday, or I think it was Monday, a colleague of mine sent me this article, and I thought this was perfect timing. This came out November 12th. It's found in the Atlantic, and is about what vets think of 23andMe for dogs. So the companies that we actually used in our own samples. And there's a really nice article. I put the link here. Well, it's under there. Why that bar's there, I don't know. And what they say is that people now come to the vet and they say, here's what the genetics say. And the vet doesn't always have enough information on the science, if the science is sound. And sometimes these results, so there's some disease loci, some that we've talked about, that it's a risk factor, right? It's not saying for sure your dog is going to die of this disease. It's not going to saying your horse is going to have this disease. It's saying it's at risk to develop it. And veterinarians are now having individuals, I've seen this in horses as well, unfortunately, that are euthanizing animals based upon a DNA test that maybe they don't fully understand. So I think there's some ownership that the scientists have to take to better communicate results, but there's also some unknowns that veterinarians and owners need to deal with as well. Okay. So I'm involved in a issue with this in horses right now. Private companies can make money by offering DNA tests. When they're a private company, they're not going to necessarily tell you everything that goes into that because they don't want anybody else to replicate it and take away their profits. And in some instances, that information they're giving people isn't complete or may not even be accurate. So I don't want to stand up here and say DNA testing is bad because I think it's a very, very good thing. But I think we have to know the limitations and know what we should be looking for and whether or not we accept it. Okay. Any last minute thoughts from anybody? Are we going to go home and genotype their cows and dogs?
I wonder if some of those breeds that kept showing up, if the reason why they're showing up is because they're somewhat closely related to whatever breed it is.
Yeah. So we had a very, very good question and point. I think you're spot on. Is that in some instances, if the breeds aren't represented in the discovery panel, those tests are going to give you 100% ancestry to something, right? It's going to proportion 100% ancestry of that dog or that cow to something. So I think in some instances, we're seeing that as picking the closest thing that it knows that is most genetically like what it should be. And so I think that's an instance where our main Anjou's getting called not a shorthorn because shorthorn wasn't in there, but a Beefmaster or Santa Gertrudis that has shorthorn ancestry in itself. So I think that's absolutely right. All these tests, all of the wisdom panel has some unknown groups, but they're going to assign 100% of that animal to something. And if it doesn't have the right something, it's going to assign it to something else, which hopefully is closely related, but not necessarily. All right, we'll see you Friday.